Okay, my video capture crashed. It's a piece of shit. Anyway, so we want OS to be printed on the screen. So I went ahead and put the colors in place for, I guess that's red background. I don't know what it is. We could set it 2-0. The foreground is black. The background is red, green, blue. Maybe it's green. I don't know. It'll be something. And then the text will be OS. We want to put an OS on the screen. And what we want to do is add at 1, jump, add at 1. We could halt. No, we don't want to halt. Okay, so I think we're all set to, well, no, we're not. Okay, so we copied the code in place, and now we write the boot record. So write blocks. This goes the same format. Let's go ahead and write blocks. I think we're done. I'm done, and I'm on. Done. I'm done, and I'm on to the next one. Okay, let's see. Pow. Okay, now let's see if it boots. So we say reboot. Number 2. And we got OS in green, just like I said. I have to restart. Okay, so let's make it reboot when we're done. You want to do that? Okay, let's see. Reboot. So every time we do this, it reboots. So now we want to turn this into a 2-stage. So you know what we do? We go ahead and call this stage 2. Stage 2. So stage 2 is going to be a file on the partition. So the bootloader, we can call this install bootloader. So install partition boot. No, let's just say install boot. Install boot. And part 2, install OS. That's okay. Install OS. And what we'll pass it is d:/kernel.bin. BIC. You know why it's BIC? Because it's contiguous. That's important. We're going to make a the partition bootloader is going to load the kernel.bic, and file name just to be. So we don't need any of this. And what do? We say file write. What am I talking about? We say file right, file name buffer size, file name buffer. So this is S2 start, file name buffer S2 end minus S2 start, file name buffer size. Okay, so that writes to the kernel.bin file, BIC. Now you know what we're going to do. We are going to cdr entry. I call these a DE. Okay. Now we are going to file find file name directory entry. File name address directory entry. You know what we have to do, folks? Let's go ahead and do. We are going to write. How about what do we call this? Write kernel. It's not a very good name. Okay, so you know what we need in now. We call this boot record, and we call this OS. So let's put this about 8 characters. Okay, so now we stage 1, stage 2. So we're going to use interrupt 13 1342. We want there's what they call a DAP. I forgot what it stands for. So there's a structure in memory. Anyway, we're going to do interrupt 13. Okay, let's move a little faster. So we want move was that hex 42? Sure, yeah, it must have been 0x42. Interrupt 0x13. So that's what we want. We want to set it up. So where do we want the DAP? Let's put the DAP down here. S1. It's, I don't know what it is, packet. So we want to jump. As a matter of fact, we don't have a set. We don't remember I said the compiler doesn't support segments. Well, guess what? We have to hand code the jump. Getting a little ahead of ourselves. Define U8. I think it's EA. That is the jump instruction. DU16. Define U16. Offset. Okay, so the boot sector loads at 7C00. 7C 7C0. Is it 7C00? No, it's just 7C. 7C. I forgot if it's 7C00 or 7C. Anyway. Okay. Now we so there's our jump instruction. Jump to 0x1 1 2 3 1 2 3 4. This is our jump instruction. Now we just have to set up the packet. So I'm gonna copy the packet. And so the packet is size of packet DU8 0x16. We want to use a 16, reserve 0. The next byte is 0. DU16. Number of blocks. I recommend always using 1. Just load them one at a time. Once you play with a few BIOSes, you learn how to make it maximum compatible. And 1 is the maximum compatible. Okay, is there only one word? Yeah, okay, that's right. Let's see. Just to be okay, then transfer buffer. Okay, we're gonna fill this in. S1 DAP buffer. We don't have to export it. And the transfer buffer we want DU32. Well, let's call it DU16 00. And then block. Okay. S1 DAP block. This we DU64. What? Yeah, that's what we want. Yep. 64. Okay. So we're making progress. So you know what we do? So it's going. We want to write our kernel file, and then we want to install the bootloader. So the reason we got the directory is so that we can patch star quote star S1 DAP block star S1 DAP block and we typecast it as a U64 is equal to DE. Uh-oh, we got clusters. DE cluster. This DE cluster. So you know what we do? We have to cluster to. Let's go ahead and I'm just going to show off the API. So we go to disk. We go down to cluster to block. We have to pass it the drive partition. Cluster to block. Uh-oh, we need the drive. Isn't that special? So we say letter to drive so technically if you gave it a file name, isn't this special? Guess what? Oh, isn't that special? So the full name the first letter of the full name is the drive, and that's guess what we need to do? We need to free is there a entry delete? What does it do? I never remember this actually. So what we're doing is we're modifying the DAP in memory, and then it's going to get written onto the partition. Okay, so it's one block. What we could do is, well, let's do that. S1 DAP block count. So this is clusters. If you really want to do this correctly, S1 block count. You know what we're going to do? We are going DV equals letter to drive. Oops. Okay, now we want to take sectors per cluster. We want to say DE size is in clusters multiplied by DV sector per cluster. If we look this up, it should be SPC, sectors per cluster. Okay, so this is a 16, U16. Okay, we're really fancy, aren't we? Okay, we're not finished. We have to okay, let's fill in the DAP first. We we have the block. We have to fill in the buffer, don't we? Okay, so to fill in the buffer, we have to enter the segment and the we have to fill in the buffer. We have the, that's all we have to do. Okay, we can do that. So move. Is this an instruction? Can you move CS? Move CS AX. And what we do is move. Now okay, let's do that. Call add at 1, add at 1, pop AX. XOR EAX, EAX. This is BX. So we're pushing the instruction pointer. You know, I didn't have to do this the last time I did this. Maybe I did. Okay, anyway. Let's go ahead and okay, pop BX. Shift. No, do we have to? Yeah, shift left EBX, comma 4. No. Move AX, comma CS. Is that an instruction? Shift left EAX, comma 4, add EAX, EBX. How about that? Okay, so we get the now okay, fine. So now we want to move into DS. So move I'm doing this different from how I normally do it. Okay, that's how we do it. Okay, now I remember. So, no, that's Okay, let's add, oh, that's what I do. That's what I do. Okay, so now we subtract EAX, comma, add at 1. Okay. So now we have, see, you might get C, here's the problem. You might get C0, comma, 0, 0, 0, or you might get okay, so you might get either of these, and what we have to do is handle both cases. So now we do shift right EAX, comma, 4, and move DS, comma, AX. Okay, so we just solved the problem. So DS is no, we didn't. I hate this. DU8, we have to dupe. FAT32, what was it? That's what it was. Code. This is not, I had a really simple way of doing this, but we're getting complicated. Okay, so oh, that's what we could do. Actually, I don't think we need to say offset. I think we can just say this. Code 1 plus. Okay. You have to do all these segments by hand because it doesn't support segmentation. So for DS. Okay, now we're almost ready. Now we just have to store the buffer. Wait a minute, the buffer is that's where we're gonna load it into 1000. Oops. Boy, I'm getting really confused. Wait a minute, it's 7C00, isn't it? So it's 7C. I think I better do this, don't you think? Yeah, I was off. I was mistaken. Okay, now so we have the data segment. We have to load the DAP address. AH42 DL drive number. Oh, we have to we haven't touched it, so it's okay. It's past DSSI. DSSI. Okay. DSSI. So we want move SI, comma S1 DAP. Okay. I think we're good to go. Okay. I have a bad feeling about this. DS. Okay, so DAP. What am I forgetting? Is that it? Is that all we have to do? I'm forgetting something. Maybe I should just run it. What am I forgetting? I'm forgetting something. Oh well, I'll just run it. See what happens. F5, here we go. SHR. You know what? I've modified the opcodes. Okay, if you want to see my opcodes, Control F SHR. Oh, we have to do CL. I knew that, didn't I? You don't have. No, you don't. Shift left, what was it? Shift EAX4. Shift left. Oh, this one. Wait. Oh, okay. That's not correct. I think you can push CX, can't you? Push CS. Pop. EX. Okay. Shift right. EX4. The assembler is not very good about errors. Let's go ahead and say offset the offset is different from what you normally shift right. Lovely. It's not the standard. I don't know what's wrong. Let's comment this out and see what happens. Cluster to block invalid. What was it? Invalid L value at cluster to block. Oh, we have to say okay. That's embarrassing. Okay. So we're almost ready. I think we can get rid of this. I know we can't we? Okay. Oh, I'm subtracting a 16. What happens if I do this? Okay. So we know this is okay. I'm just gonna it's a 16-bit offset. Oh, why don't I do this? Let's see. U32. How about that? Okay, here we go. Number 2. Okay, we did not load it. So let's reset. Okay. Let's look carefully. Okay, AX call pop BX push CS pop AX shift left add BX AX subtract 1 plus that shift right move AX DS Oh, we didn't write the DAP. What am I talking about? What's AL? Nothing. AHAL. Okay, so DL has been preserved, and AH42DL DSSI. Packet, we got 16.0 number of blocks. We should check that. You know, let's dump okay, let's go look at drive D. Oh, there's no kernel. There's no kernel file. File right. Well, that's not good. File name, file right. Oh, we format down here, don't we? Okay, well that'll do it. No, actually that's not gonna be the problem. But let's do that. Okay, I booted number 1. Control D. Okay, there's the kernel file. Let's analyze the kernel file. Let's go dump it. So drive D dir. I think we can, it's 1F characters. Well, of course that's not correct. Is it? Oh no, that is correct. Okay, so I think we can say dump. Okay, I think we're let's we shift right 4. Maybe that's, let me check if it's EA. I'm gonna cheat and look at EA. EA 00. Let's look at the block count in the boot sector. Okay, so we want to let's dump the boot record. We could unassemble the code. Unassemble unassemble IP count segment. We want unassemble in number of bytes. Unassemble in BR code, comma S1 Okay, let's see how we're doing here. y8hgu4Ylk6U call pop bx push cx pop ax shift left 4 add bxax. Oh, wait a minute. Shift AX. Oh, yeah. We have the wrong number here, that's for sure. So the subtract is wrong. It's a huge number. It's a 7F number. Okay. So you know what we have to do? It's minus S1 start. Okay. 80. That looks a lot better. Let's try it. Let's let it work. Okay, number 2. Uh-oh. Crash and burn. Does 80 sound right? 50A is 5A is anyway. Shift right, move AXDS, move, that looks wrong, A6, okay, well, that makes sense. Okay, so DAP minus this one start. One more time. Let's try it. Number 2. No, it didn't work. Well, that sucks. I hope we can get this done. want to start over and make a new video. A3. So the value should be 5A plus the offset 42AH, interrupt 13, jump. How come it's a jump? Yay. Zero, zero. F8, what is that? Is that the, what is that? F8. So the 6, that's the count, F8. Well, we can't have. And the block number, oh, the cluster number looks awful. Okay, so the start of the cluster, the start of the drive is 8. This is the drive. Those are the drive blocks. Okay. So the count looked off, and the let's go ahead and print these. DE size. Oh, the size is in bytes. Of course that's wrong. Okay, size is in bytes. Divided by block size. Plus block size minus 1. Oh, it's not clusters. What am I thinking? Okay. Oh, well. Okay, let's see what we have here. Block. That looks correct. That looks correct. Okay, let's let it rip. Here we go. Number 2. Oh, we did a stage 2. Okay. So that's how you do it.